do some processing, most of the time the input goes back to the server through an API call or something. So it gets processed there, and then it comes back with the result for us. So this is the more general way we might have aware of. The second area is edge devices, right? Where all the processing happens on the device without really going back to the server, and it doesn't really need to be connected to the internet, or even if it is connected to the internet, not all of the data is sent over to the server. Uh, Maybe just the finished processing, or just the alerts, like I have shown, just alerts goes into internet, through an API call. So another area is still on mobile, but instead of going back, we can do on device machine learning inference. Sim- I nowadays even some of the services on Google still works offline on the device. Like when you, for example, when you type a word, it on the keyboard it kind of predicts what would be the next word you might type. So earlier this might have been kind of a strict handwritten rule kind of for looking into a kind of dictionary and then trying to predict. But now this kind of moving into learning the pattern of how you type, and just trying to understand and use machine learning to give better prediction. They're even trying to do it on device, even if it is online or offline, it would still work. So another kind of new area is developing is in-browser, inference. So let's say if you go to your website, for example, some processing like face detection or anything, or hand gesture detection, they don't really need to go again back to the server. They need to run this machine learning uh, models in browser, right? In your machine, using your machine's compute power. It's just another area that is coming up using JavaScript and other techniques. So this is kind of a broad overview of in the real world where machine learning or AI is making interactions with people. Can you go to the next slide? Next slide, please. Yeah. So if you look at the main difference between running something on the cloud or running on an edge device, like an embedded system. One second. So as I said, on the cloud, it goes to the backend through an API call over the internet. On the edge devices, everything happens on the device. So on cloud, the restrictions are not that strict compared to an edge device, because you don't have to rely on the phone, or somebody's browser to do the processing. For example, the image can go back to the server, and on the server you might have larger processing power like GPU or other things. Uh, so one thing is there is possible latency because it has to go to the server and get processed and come back. And again, it is subjective to the internet connectivity, right? It has to be connected for it to work. On the other side, edge devices are more known for being able to process these things in real time. For many cases, like processing CCTV footage or anything that has to happen like in real time, or uh, at the door, if you have a like face recognition system or something, it has to be more quick and real time. So this uh, brings in an advantage with some challenges, right? So this can work offline, uh, not needed to be connected all the time, and the actual data doesn't really leave the device. It just happens there. So in this view, I mean, there are some privacy or security issues on the cloud side, right? Whatever the data that we are sending is basically goes back to somebody's server or somebody's machine. So there is concern that you know sensitive data is going back, and of course security challenges. What if that server gets compromised or being used for other purposes on the edge? I mean, privacy wise, the data might not leave the device, but that also has some security challenges, meaning how much of general security complaints that can be done on an edge device is very less compute. And even if somebody gets access to the device, what happens? So, security wise, even on edge device, there are some challenges, but on edge, privacy. Next slide, please. So just expanding on the challenges in edge computing, right? So this is again more visible to us, in our team, since we work on the edge device, right? We process all the frames and uh, most of the information on device. So when we think about building an AI system on edge devices and building a model, so apart from building or creating a machine learning model that is capable of doing something, there is a whole other area that we need to be thinking about. On the device that we have on hand, like how many CPU cores that it has, and what frequency the maximum frequency the CPU can operate, and how much memory it has, and how much disk space. So because most of the time, these AI systems are runs in the cloud, where these are not a constraint, uh, and even people don't really look at how heavy the models is. So these things becomes very important when we are running this on edge. So even normal CPU might not be enough for more heavy neural network processing, and we have to think about what are the accelerators that we can get. So GPUs are really good at doing this task, but they come at cost, right? On an edge device, how many GPU cores or how much capabilities, and even the newer ones like TPU or NVIDIA is coming with deep learning accelerators and everything. So even they have some limitations. Uh, so they even consume more power, and if you're running a machine learning model like 24/7, then the device gets heated, and once you deploy this device to a location, and how do you deploy newer version of the model to that device, and how do you access the device remotely, and how do you monitor the health of the device, how it is doing. So these are kind of general challenges in deploying AI on to the edge. Next slide, please. So in particular, computer vision on the edge, as we are building uh, from the beginning, for example, the neural network architecture that we select, and if you have to run in real time, how many frames per second it can process. Uh, and even after developing all of this, we still have to optimize the model after the model is ready. We still have to go into the another phase of model optimization that is kind of specific to the hardware architecture. So some of the recent advances in model optimization, like TensorFlow coming in with TensorFlow Lite and TensorRT from NVIDIA. So they are kind of helping uh, optimizing the model to run in edge devices with more efficiently. So mostly for prototyping or experimenting, Python is mostly used. But generally, people have an idea like Python or other recent languages kind of taken over, or C, C++, is not really used that much. But that's not really the case, because even if Python comes in with more convenience, but it comes at a cost, right? So when we are looking for really high performance, we still prefer using C or C++ on edge devices. Yes, that
Sir, your voice is breaking, sir.
Sir, no audio, sir.
hello.
Sir, voice breaking, sir.
Yes, sir. Yeah, now it's audible, sir.
Okay, let me check my internet. Yeah. Can you hear me now?
Yes, sir. Yes, sir. It's fine.
Right. Continue starting with frame, so that if in a sequential process, things have to happen one by one, right? That might create some lag. And even we have to think about high-level algorithmic optimization. We really need to do something at a particular point. So this is all kind of doing all the best we can do to get a better performance on edge device. Can you go to the next slide, please? So recent advancement in devices, better GPUs are coming in, almost every 6 months. NVIDIA is announcing, better GPUs, and even they are coming up with AI-specific accelerators. For example, Google has its own device. Yeah, if you can play that video. Yeah,
Sir, can't hear the sound from video.
Okay, well, then just let it play. Just not. Yeah. Even where the training data is not really available and on a large scale. So in general, for image recognition tasks, like for example, recognition objects like car or other objects, it's easy to get a large amount of data for training machine learning models. But when it comes to healthcare, just to get access to the data, right? For example, if you are training to detect a tumor on an MRI scan, you don't really have a lot of open source data to train on, right? They are really sensitive data, or even if you partner with an institution to get data, it's still not really that much large. And even recent techniques like WebAssembly is kind of helping to run normal C++ code on a browser, and even just deploying these ML models on mobile has been a difficult process, but I think the integration is kind of becoming better for mobile design. Can you play this video?
Just a minute, let me just check it, sir. Audio is not
Inside
clear.
every cell,
I'll just check the
billions of tiny machines are monitored.
just a minute.
They carry
Yeah.
oxygen in the blood. Let your eyes detect They underpin every biological process in every living thing. Each protein has an intricate 3D shape that defines what it does and how it works. We know of over 200 million proteins and counting, but we only know the exact 3D shapes of a fraction of these. Unravel a protein, and you'll see it's like a string of beads made up of 20 different types of amino acids. Interactions between these amino acids make the protein fold as it finds its shape out of almost limitless possibilities. For decades, a community of scientists have been working on a way to figure out a protein shape just from the string of amino acids.
Inside every cell
This
of your
is a
body,
major challenge.
Sir,
in
audio
understanding
could be heard now,
biology.
sir.
So
Yeah, now we can hear.
billions
That's
of
good.
tiny machines are hard at work. They carry oxygen in your blood, let your eyes detect light, and even make your muscles move. These machines are proteins, and they underpin every biological process in every living thing. Each protein has an intricate 3D shape that defines what it does and how it works. We know of over 200 million proteins and counting, but we only know the exact 3D shapes of a fraction of these. Unravel a protein, and you'll see it's like a string of beads made up of 20 different types of amino acids. Interactions between these amino acids make the protein fold as it finds its shape out of almost limitless possibilities. For decades, a community of scientists have been working on a way to figure out a protein shape just from its string of amino acids. This is a major challenge in our understanding of biology. So we created an AI
Indeed.
system to solve this problem called AlphaFold. It's trained on the sequences and structures of about 100,000 proteins, painstakingly mapped out by scientists around the world. Today, it can accurately predict a protein shape just from the sequence of amino acids. AlphaFold's predictions could enable progress in all sorts of areas. Imagine a future where we could understand diseases more quickly and develop drugs to fight them, or one where we could use enzymes to break down plastic waste, or even to capture carbon from the atmosphere, all with the help of protein. There's a lot of work to be done, but unlocking the shapes of these building blocks could help scientists better understand the natural world and perhaps expand our knowledge of life itself.
This is kind of a recent breakthrough that happened. You might have seen them in the news or something just few weeks back.
Understand condition.
So the company called DeepMind, right? They built an AI system to solve this problem of protein folding. So so this is kind of a long-standing problem in biology. Almost like more than 50 years.
Inside every cell of your body,
Just being able to predict and understand the actual protein that's going into our human body has been proved to be really challenging. But now with the help of an AI system trained on known proteins, the AlphaFold team, they are able to predict the protein shape at more than like 90% accuracy. So I think this is kind of will help a lot in terms of even like drug discovery and understanding diseases, viruses like COVID, right? This will fundamentally unlock many possibilities. Can you go to the next slide, please? So this coming from around the world, from researchers and organizations through open source tools and publishing their research fully and making the code or making many resources available online. So this has been really helpful for anyone who is been like building a solution to a problem. Even we use and rely on some of these open source tools like TensorFlow and PyTorch. Uh, right now, like anyone who has access to an internet connection can access most of these resources. Yes. Can you go to the next slide, please? So, in healthcare, there is still a lot of concerns in giving access to the data, and there is a lot of regulations that is there to access the data, right? For example, the particular device that we are building will be placed in every room in the hospital or kind of nursing home. So the data or the video stream that we are getting in should not go outside to the backend server or something. So we kind of have to process all of those data on the device, and there is a lot of regulatory complaints. So just to address these issues, people are still working on what are the ways we can create better AI system, but also like addressing this data and privacy issues. So one kind of example is the new area of research into like federated learning. So this is a little bit different approach from in a normal supervised learning model. Like usually you gather data and then you train it on a server, or you do the training and the experiments, everything on the company side, and then you make the training model and deploy it to the production. So but if you don't have access to the data, the whole the training process just stops. So federated learning is kind of instead of taking or collecting all the data and bringing to the training model, what if we take the training model to the training data where they are located. For example, let's say each hospital has their own data. Instead of taking all the data, if we bring a model that is that can train on that particular data and the patient, and it can stay in that institution. Once this kind of model is trained at multiple places, what if we can bring the trained models together instead of the data? Now they train this tiny model. If we can create a global model that can learn and consolidate what this tiny model can learn, without really
హలో
knowing
ఉన్నాడండి
each individual personal data behind each training model.
ఈ సాంగ్స్ యాక్టివ్ అవుతాయి.
So this is kind of another approach to address this issue. Have been, healthcare. I mean,
Sir, your voice is breaking, sir.
The brain needs to, how do we yeah, is it better now?
Oh, yes, sir. It's fine.
Oh, okay. Sorry about that, just connectivity. So I was saying about this crowdsourcing, being able to get access to this medical data, but without really identifying the personal information. This, that's still kind of an ongoing area of development at this time. Being able to build this AI system with this data. And another area is kind of explainability. So even if we successfully train a model and predicts or recognizes whatever we want to do, but how do we actually explain the predictions or the decisions that the model is taking? If something goes wrong or questionable decision is taken by a system, how do we explain the behavior or why it did what it did? So that is kind of another area people are trying to put efforts into. For example, a machine learning model trained at the company Apple for creating credit system is assigned more credit data for a particular kind of demography of people and than the other. So if you look at the predictions and why the system has been making those decisions, it's kind of difficult to go back and explain what made it in a way that the model behaves. So that is again kind of implicit bias kind of coded into the model through the data that we use for training. For example, the data has to be very diverse. The training data has to include as many diverse scenarios as possible, so that it doesn't get concentrated on one type of data and it just leans on that side. And even other ethical choices, right? How these models are being used in in what scenario, and just assuring that it doesn't really make or hurt any human value. For example, I recently came across a team that is trying to detect heart rate and other medical information just from the photo of person, without really other sensor details. How accurate that could be, and if you rely on that data to make other decisions, how reliable it is. So those kind of ethical questions and explainability is a lot more important when it comes to healthcare. Yep. Can you go to the next slide, please? I actually have a few videos on this. Yeah. Let's go one by one. Just double click that video. I think it should.
Nana,
Marco Roccioli.
ma?
Mi consiglio.
So this kind of another example where robotics is evolving more into human-like or even some of things that humans cannot do. So this kind of will help, for example, where it is really hazardous for humans to go into, or even very difficult situation where a human interaction might put them at risk. We can let a robot go into the, for example, if a gas leak has happened, instead of going a human into the space and inspecting it, a robot can go in and help. So I mean, this is not completely new. We have had robots that can kind of help in scenario, but mostly they were manually operated and manually controlled. So only recently, with the help of AI, we can put some intelligence into this robot, and they can detect and go around themselves without really waiting for commands from a human for every single turn and move. Okay. So this is kind of another robot that from the same team at Boston Dynamics. So this kind of totally breaks how robots are seen and perceived. Generally, the robots are not really this much flexible and human-like in terms of doing this action and just being able to hold things the way human does. Has been really challenging for a long time. I mean, other than science fiction movies, in reality, it has been really challenging. These advancements are has a lot of hope and advantages for for a better tomorrow. Meaning not just in terms of medical or healthcare analysis, but just creating well-being for and safety for humans in a broader sense. I can go to the next slide. Yeah. So this is kind of I want to finish it with your hope and a better not long term future, but in the near future, where robots in general AI systems can help us in terms of building a better life, better wellness, um, even in the medical space and even in general health. Yeah, with that I kind of finishing the presentation. Can you just go to the next page? Yeah, I think we can have some open forum for Q&A and discuss anything that you might have on your mind.
Any question and answers, please ask. Participant side.
Yeah, just any questions you have on your mind.
Sir, from my side, you were telling about Jetson Nano Edge device. What will be the cost
Yeah.
for that, sir?
So Jetson Nano generally costs like $99. But they use the recent one at lower cost at I think $59. So in India it should be like less than like 5,000.
So will it be better than Raspberry or Arduino to do projects based on AI?
Yeah. So mostly Raspberry Pi has been the go-to device for projects so far, right? So now it's kind of being Jetson Nano is kind of the Raspberry Pi for AI, because the GPU it has neural network processing and the whole range of even software optimization that NVIDIA is coming up with.
Okay.
So yeah, Jetson Nano will be a good starting device for any AI process.
Okay, sir. Thank you. Participants, any other questions from your side?
And even NVIDIA has other range of devices like NVIDIA, I think Jetson, NVIDIA NX is kind of has the best compute in terms of edge device that comes at